So today I will compare and write equations of parallel and perpendicular lines. I'm not going to spend a lot of time on parallel because, like I said, on Desmos, you guys showed that you did very well on it. But write equations of parallel and perpendicular lines. First thing is make sure that our lines could be written in slope-intercept form, and they're both there. So they are. This one is close, except they have the two mixed around. So I rewrote that one as y equals negative 3x plus 2. And so then I looked at this one, and when I compare lines, a couple things I always want to compare is I want to think about their slope, and I want to think about their y-intercept. On line 1, the slope was negative 3, because we see that right here. And then we see that its y-intercept was positive 2. So this was on our line 1. On our line 2, on our second line, we then see that the slope is negative 3 and the y-intercept was negative 1. So when we compare the two, we see that they have the same slope. On both of them, their slope was the same, and because their intercepts were at different points, the lines are not crossing, and we can see that they are going to be parallel. When we make parallel lines, we need to have them having the exact same slope. And they just have to go a little bit spaced in between them. So you usually can do that with a different y-intercept. I do the same thing on number 2. I look at my first equation, and it said 4y equals x plus 8. Well, let's go ahead. If you have not done that, go ahead and write that in slope-intercept form. What is 4y equals 8x in slope-intercept form? How would I rewrite that? What's it going to become? A couple people a little bit, a few more seconds to work on it. All right, Katie, what'd you get?
Y equals 1 over 4.
Okay, so first thing is if I'm dividing by 4 to get my y alone, so y equals 1/4 x plus 2. So we said.
Oh.
So that's all we had to do was we had to get y by itself on the side. I'm going to look at my second equation, and it said y minus 3 equals 1/4 x. And the only thing I have to do to this one is to do what? Brendan? Yeah. Just get the 3 on the other side. So now my two equations are y equals 1/4 x plus 3. Here's my first equation, and here's my second equation. On both of them, if we're comparing, are their slopes the same? Yeah. If we look at this first one, the slope was 1/4, and its y-intercept was 2. On our second line, our slope was 1/4, and the y-intercept was 3. Yes.
I think the equation is y plus 3 equals 1/4.
Oh, is that a plus sign on there?
Yeah.
Well, it's, oh, then it would have to fit. Okay. So, what Huff noticed, sorry, I'll change a couple little things. I thought this sign right here, I looked at quick, was plus or minus. But actually, if you match it up with our graph, here's our y-intercept down here. Oh, they would have had it been a minus. Oh, no, you're right. It's down here, so this would have had to been a plus originally in the equation. Originally, it was plus 3, so we have to subtract 3. Subtract 3. Should have put that part up there. So then we would have got -3, which is what we would have got. That's a good point. I should have been double checking. I did do that. Should have been double checking to make sure this line right here is being graphed. So if our y-intercept is -3, 1, 2, 3, that should be right here. And then I check my slope, rise 1, then 1, 2, 3, 4. Making sure that's working. Our first line, it was +2, so 1, 2, and then 1, 2, oops, rise 1, then 1, 2, 3, 4. Okay. So when we compare the two, what is the conclusion we can draw about the two lines if they're all parallel? That the main way to make parallels, you have to have the same slope. Okay? And then you just have to be offset with each other. If we look at this one, this is where we look at these lines and if they're perpendicular. First, I want to write each line so it is in slope-intercept form. Is this one in slope-intercept form? Yeah. I have y equals 1/3 x plus 3. Don't be throwing things. And then the next line, oh, so let's stay on this one, I'm sorry. What is the slope of this first line? 1/3. Then what's the y-intercept? 30, good. And which line is it? Is it the black or the purple line?
Black.
Yeah, it's the black line. Let's double check. Y-intercept's 3, 1, 2, 3. And rise 1, run 3. All right, good. So this is the black line. If we go to the next one, I have y plus 1 equals -3x. Should be fairly easy for you, but what is this in slope-intercept form? What change do I have to make, Maddie?
You have to subtract 1 on the
All right. So we get y equals -3x minus 1. Let's double check that. Here's our y-intercept. -3, 1. 1, 2, 3 over 1. So it's the purple line. What is the slope on this one? -3. And the y-intercept is -1. Alright, so now we're looking to see if they are perpendicular. What do we notice about the slopes? Maya?
The purple slope is the opposite reciprocal of the black slope.
Good, I like this. Opposite reciprocal. Now you're going to make me spell that. Is that right? Close enough. It's fine. Alright, so the slopes have to be the opposite. So if one slope is positive, one has to be negative. And then they have to have the reciprocal. So if it was 1/4, you have to have 4/1. 2/3 had to be 3/2. Why does it have to be the opposite value? Why couldn't this one just have been 3/1? Tatum?
Because they're crossing, so one's going to be positive and one's going to be negative.
So if I would have made this, like real quick, if we just look at this, here's my y-intercept of -1. When you're doing this, this is why we can experiment when we're trying to understand something. If I would not have made this a -3x, and I would have said my slope was just 3x, that means I would 1, 2, 3 over 1. 1, 2, well, I'm going to go off the chart. But my line would have been something like this. And then it's cutting into it as an angle, and it's not going to be perpendicular. Yes?
So if they went along like the x and y axis, then wouldn't one of them, would they both be positive?
Say that again.
So like if it's a 90-degree angle, couldn't it go past like the y and the x axis to make like would they both be positive?
Both.
Yeah.
They both be on lines.
Yeah. So would they both be or something zero? Or,
Will they cross the x and the x-axis and y-axis?
well, like
Sorry, I'm just not doing your
if the lines went along, if one of them went along the y and the other went along the x, like they would still intercept, but they wouldn't. One of them wouldn't be negative.
Oh, you're saying like if one line was a vertical line,
Yeah.
and then one was the horizontal here?
Yeah.
Well, that's because one of our slopes is going to be 0, which you can say is positive or negative. But then remember the other slope is that undefined one. That's kind of a good question. It's a confusing one. Alright, so let's look at this one real quick, and then I think we'll be able to move a little faster through this. But this was the part that we were struggling with. The first one, y equals 2/3 z. Oops, I don't know where I got z from. Just checking you're paying attention. So we do that one. What is the slope? Good. But what's the y-intercept? When they don't give you one, what's that mean? Yeah, it's 0, 0. So that's this one. And then I see rise 2, run 3. Good. The one I want you guys to work on, write this in slope intercept for me. It said negative 3/2 x equals y plus 2. Go ahead and write that in slope intercept form for me. You notes with us?
Isn't the reciprocal just multiplied?
Oh my god.
Notes with us. Alright, someone have it yet? Think? Emily?
Y equals negative 3/2 x minus 2.
Say it again. Y equals.
Negative 3/2 x
Okay.
minus 2.
For some reason I thought you said an 8 in there. So, if I would have done this, I would have just subtracted 2 on this side and minus 2. And then I'd have the negative 2 minus 3/2 x equals y, which of course I would rewrite as y equals negative 3/2 x minus 2. Okay, what is our slope? Negative 3/2. And then our y-intercept is negative 2. When I look at the two, are the slopes, look, I forget who told me this, was it Katie? Are the slopes opposite? Well, this one was positive, is this one negative? Okay, so they're opposites. Are they reciprocals of each other? 2/3, 3/2.
Yes.
So we would then have our perpendicular lines. So that is an easy way to check. This should be pretty quick and easy for you. Examples of perpendicular slopes. So if 8 is one of the slopes, or I could say 8/1, what would have to be the second slope?
Negative
1/8. Good. Remember, we're thinking of our opposites and reciprocals. So if B was -1, what is its perpendicular slope? Josie?
Positive 1.
It's going to be positive 1. There is no reciprocal because it's 1 over 1. Ooh. What if a line's undefined? I kind of want to go back to you on this one. All right, Josie, I know I just asked you, but what do you think? 0. This is the one that she was asking about earlier. If it was on the y-axis, would the other one go on the x-axis? Yeah, but do they have to just be on the y-axis and the x-axis? No. They can be, if I scrolled up to here, like the one could be here, and the other could be like that. But we would have horizontal and 0. What about 1/2? It's 1/2. All right, great.
Negative 2.
Negative 2. Do we have to say 2 over 1? No. Identify the slopes. These should be kind of reviewed, but we're going to put them in just in case you get lost or confused. You can go back to this. Identify the slopes. So for this first problem, my question is it in slope-intercept form? Yes. So what is the slope parallel to the line? What would be the slope that's parallel to y equals 4x plus 5? What would the slope be, Katie? 4. This was its slope. So what would be the slope of it being perpendicular? Negative 1/4. Number 2, what is the parallel slope? Let's go to the second question. Y equals negative 3x plus 1. Grace? Negative 3. What about the perpendicular slope? What? 1/3. And the last one, y equals x minus 7. What would be the parallel slope, Maddie? Just 1. And what would be the perpendicular slope? Katie? Negative 1. All right, I think you guys are starting to get a hang of this. Work real quick on this one. Which lines, if any, are parallel or perpendicular? How are we going to do that? What are you going to have to do, Maddie? Find the slope, y-intercept for each of them. So, like, I'll give you a hint on line A. It's already in slope-intercept form. So, I would say slope. What is the slope?
5.
Good. And the intercept was negative 3. Go ahead and solve for B and C. Okay, if you solve for the lines on line B, did you get the slope intercept form to be y equals negative 1/5 x plus 2?
No.
Oh, crap. What did I do wrong?
No, I got 2 over 5. Plus 2/5 instead of plus 2.
What? Did I mess this up?
You divided by 5 because it was 5y. But you
Break
didn't
the
put
whole
the
on
2
here.
over 5.
Y equals 2 minus your x minus your x. 5y
You wrote
equals
it down, you just didn't do it.
Yeah,
plus 2 divided by 5 divided by 5
I need to break the
y equals negative 1/5 x plus 2/5.
Yay! You just put 2.
Oh! I'm like, I know I did this first. Okay, so, see, once again, so see you guys are paying attention. Yeah, pretty much. I didn't win the Mega Millions last night. I was planning on not teaching today because of that, but I didn't hit the money. Alright, so, and he saved a couple bucks. Alright, so, what is the slope on this first one? On line B? Negative 1/5. And the y-intercept was 2/5 if you did it right. And for line C, our slope is negative 1/5. And the y-intercept of 0. They didn't have anything. So, are any lines parallel?
No.
Good. So we see that line line B and C are parallel. Yeah, is that all we have? Maddie?
Line A and B are perpendicular.
What about line A well, B is parallel to C. Is A perpendicular to C?
Jace and B.
Yeah. So I'm going to say line A is perpendicular to line B and C. Okay, do we see how we identified those? Negative 1/5, negative 1/5 for slope are the same, so those two lines are parallel. But 5 is the opposite reciprocal of the slope, so it has to be perpendicular. Last one. I think I want to finish this one and then I'm going to be done. I'll finish this one, then I want you to have some work done. Write equations of parallel and perpendicular lines. So it says write an equation for a line that's parallel. So it has to be parallel, showing me that means I'm going to have the same slope to the line y minus 5 minus 2/3 x and passes through the point negative 3, 0. So the first thing I'm going to go ahead and do is we need to change this.
I think it should be y equals.
Does that say equals on there?
No, but I think it should.
I know, I was going to say we need to make it so it is.
Oh, it's just on your window.
On mine it isn't? Okay, so it is. So the line is y equals 5 minus 2/3 x. I was like, I said that, I was like, wait a minute, I don't remember having this problem. I'm going to rewrite it so it is in slope intercept form now. So my slope is negative 2/3. All right, how do we come up with an equation when it has to pass through this point? Maya, do you remember?
Do you plug in the points for y?
Just right here and here? Nope. We're actually going to use another type of line equation. Point slope form. What was the point slope form? Y minus y1 Oops. Equals slope. Okay, so when we're having to go through this point, we can go to point slope form. And now I'm going to plug in the information I know. So I'm going to make this y, and then what is y1? 0. So I'm going to say minus 0 equals, what was our slope that we have to make it parallel? Negative 2/3 times, in parentheses, x, and the x was negative 3. So do I leave this as x minus 3? It needs to be plus. Good. Point slope, we need them the opposite. Alright, so how do I do this one? Maddie?
Don't look at both of these cancel each other out, or so one of them has to be negative.
No, they don't cancel anything out yet.
You'd have to do negative 2 times 3 and then 3 times 1.
Good. So we're going to distribute this, right? So I first do negative 2/3 times x. So right in here, I'd get negative 2/3 x. But then I also have to distribute it to here. Negative 2/3 times 3. And when I do that, now can those kind of cancel out? Maybe that's what you were meaning. I thought you meant like you would get rid of this whole fraction. On
No, I stopped for like the 3. Go for the 3 since they can't do that out, so just make it negative 2.
Okay. So then we'd have negative 2. And on this side, we have y minus 0. If I'm minusing 0, do I even need that?
No.
So now I have y equals negative 2/3 x minus 2. Is that in slope-intercept form?
Yes.
So I'm all done. The line that is parallel is this. And I'm going to check real quick. My slope was negative 2/3. Is that the same as this one? Yeah. So I now have a parallel line. Okay, because of time, I am going to stop. I know there's 2 questions left. Oh, 1 question. I lied. The only difference on this one, write an equation for a line that's perpendicular. The only thing different is they want a perpendicular line. So we would solve it the exact same way, but when we found its slope, we'd have to write it as the opposite. I can tell already on this one that the slope was 1/3. So in my new line, we want to make the slope what? We want to make that slope negative 3. But you'd still use point, intercept slope. I can't say that.
Point slope.
Point slope form. I hate that these are all like named the same. So point slope form, and you would solve using your x a negative 10 and a negative 3 for your slope. All right, so I want to go over a couple things real quick because I need your full attention. So don't start your homework. I need you guys to really pay attention so you don't have late work. Your homework, we're going to have a bunch of it. And I'm sorry about that, but we're doing the same in every 8th grade algebra. Miss Majors and Taylor doing the same thing. First, the lesson that we went over, this is one of your homeworks. And yes, it is due on Monday. It is over this lesson. So I would suggest doing this one first. page 321, 324, 2 through 14 even, and 20, 22, 23, 26, 32, and 36. That's one of the assignments, and it's right here on the board. Your next assignment, since we have a 4-day weekend, kind of, we don't have school till Monday, but we have to stay on top of where we're at on our pacing. You are going to go to day 8 and 9. It's next in our OneNote. And it's talking about fit align to data. There is a YouTube video link. You will watch that link. While you are watching that video, I would split my screen so the video is on half, my notes are on half, and take your notes with it as you go. Your homework, I'm going to hand out to you as well. You have 2 worksheets you're doing over this. 5.6, which looks really big, but it's because they have graphs, so they don't put many questions on the page. And 5.7. So we have day 8's homework, 8 and 9 video, 5.6, 5.7 worksheet. So really you're doing 3 homework. I'm going to give you one other worksheet. This one is totally optional though. This one I'm going to give to you so you can start. We're going to skip these ISTE ones that we already had in because we're doing a little bit different with ISTE using Desmos. But we are going to start looking at our review. Our goal is to take the chapter test on Wednesday and Thursday. So I'm going to hand out this day 11 review, and then we can do it on Monday, look over it on Tuesday, and test on Wednesday. But if you want to get a head start and you have time over the weekend and you want to start looking at this to study, because I know so many of you are doing a great job staying ahead of the game and studying, you can start looking at this so you can come ready for questions Monday. If you don't have this review done on Monday, you are not getting it marked off. You're not getting late work. I'm not giving you a 0. That one is totally optional. I'm just going to give it to you if you have time. But you do have today's homework to do. Watch days 8 and 9, and then it's 2 worksheets. Any